The packet is over in the blue thing over there. Do your best you can to catch up here. Okay, today we are going to be going over the 4 basic constructions. So on again, page 3 and page 4 in the packet. We're going to go through them with a compass and straight edge. I'll put steps up here. I'll go through the constructions. But essentially, if you know these 4 constructions, you can do every other construction that you need, because every other construction is made up of some combination of these. Okay, so that's what we're going to go over today. Tonight, your homework is going to be on Delta Math. You should have a little bit of time at the end where I can show you kind of how that works and whatnot. But the big idea today is not that you can just complete what we're doing, but you understand what I'm doing, why I'm doing it. So I'm going to talk about all of that as we go through these 4 basic instructions. Okay. For the purpose of me doing this on the board, it's not perfect and whatever, but I'm going to like make this into my compass so kind of using it. I'll also use this and refer to it. But remember, this little circle thing right here is kind of your point of your compass, or where you're putting your center of your circle. And then you slide your slider to measure your stuff. A reminder from yesterday, this is not a ruler. This is a straight edge, okay? You're not measuring something with this ruler, okay? Whenever I say measure something, we're measuring it with the compass. That is the way that Euclidean constructions were done. That's what we're going through here, okay? So we'll talk about those things a little bit as we go here. Okay, so we're going to start with copying a line segment, which is as simple as it says, it's copying a line segment. But the question is, what do you have to do? So I'm going to write steps as well as the constructions, because what you are going to be doing Friday and Monday, probably a little bit of homework over the weekend, maybe a little bit of homework Monday night, and then turning in on Tuesday is 9 constructions that you have to figure out how to combine these and do those things. Okay, so I'm going to write the steps. You're going to be doing the same thing. Anytime I put my pen to the paper, I'm going to write a step. I did this. Okay. Anytime I pick up my compass, it's going to be my compass. I'm going to use it to help me figure it out. But anytime I pick up my compass, I'm going to write down what I did. Anytime I pick up my straight edge, I'm going to write down what I did. Okay. That's how your steps go. So first thing I am going to do is simply plot a point A prime. That does not require a compass or a straight edge. It just requires your pencil, because you can plot that point anywhere you wanted. Doesn't matter, doesn't affect anything else. Okay. So step number 1 is that I'm just simply going to plot A prime. I'll probably go back and forth between the words of plot or draw or whatever. Those are all the same thing. Okay. Step number 2 is that I'm going to make a ray from A prime. That's the way that I can describe that there. Doesn't matter which direction you go, but I want to make a ray from A prime. Anytime you make a segment, a line, a ray, you are using your straight edge. Okay, that's the tool that I'm using. I need to make sure that this ray is longer than what AC is. I am not sitting here and taking and saying, oh, this is blank number of inches and I'm going to do this. I'm just visualizing it, looking at it, and I'm making a ray. It honestly doesn't even matter. I can make this way, that way, whatever way I want to go. Okay, I am just simply making a ray off of A prime that I'm going to be able to measure off of and go from there. In order to copy a line segment, it is a segment, which means it has a measure to it, then you are going to have to measure some stuff, okay? So step 3 in this case is going to be, and I'm going to put measure in quotes again, because really this is a step that you don't have to write down, but I'm going to write it for the first 2 that we do, and then I'll kind of skip it and explain why in the next 2. But I am going to measure segment AC. Now, when you measure something in Euclidean constructions, you are using your compass. So what you are doing is you're taking your compass. You're putting the little center of the circle at A, and you're going to extend your slider to C. Way too big up here. So I use this as my compass, and what I'm doing is I'm measuring, and I'm going to figure out where I am to get from A to C. So essentially, that's my slider there, and then this is my little center circle. Right? So you measured AC. Your compass should be set at that measure then. For me, I have to like kind of pay attention, but your compass should be set at that measure. You have it. Okay. You are then going to create circle A prime with radius equal to AC. Now, before I do this, I want to make sure we understand this idea. You're going to see some notations. You're going to use some of these notations. Okay. Circle is a circle with a dot in the middle. That's the symbol. A prime means that's the center of the circle. So I'm going to make circle centered at A prime. With, you can write with, or you can use a W slash, that's actually shorthand for with. Radius equal to AC. Notice I didn't put a bar over it because that's a measurement. So we just measured AC for a reason. We figured out how long this was, so we can then take our compass and come down here and make ourselves a circle. Now, here's something else to know. You do not have to make the entire circle. Right now, all we care about, the only part of the circle we care about is this little part right here that's going to intersect that ray. Okay. However, you do need what are called construction marks. So if all you did was make like a little dot with that compass, that's wrong. Okay. You need to show me that you were at least making part of a circle. So if you notice how I made that little arc there, okay, I need to see, and I'm going to call them construction marks. I need to see construction marks when you're doing construction. Okay. So I need to see at least a little bit of that. So we made circle A prime with radius AC. Did we make the whole circle? No. Could we have? Yes. Okay. But I'm going to make it simple on you guys. In some parts, we're just going to draw a little bit of it. If you want to make the whole circle, do it. Okay. Then we are going to plot C prime, but we can't just simply say plot C prime. Because again, these steps, and it's going to tell you that on tomorrow's activity, is these steps are meant to where anybody else could recreate exactly what you say if they follow them. And I will, as you work through them, explain to you and show you how I could do it differently if you don't do it correctly. So if I just say plot C prime, well, I can put C prime up here. Why not, right? I know that's not what you're asking me to do. That's not what you're telling me. Okay. So if we want C prime to be right here, what we have to do is we want C prime at the intersection of, and then we need to say what that is. You're going to be finding intersections to find points. And so in this case, it's the intersection of, I'm just going to call it ray A prime. That's not a exact definition, but I think everybody would understand what we're talking about there. And circle A prime. Okay. In this case, we only have one circle A prime. So when I'm naming that part right there, I can just call it circle A prime. If there were two circle A primes, then I would have to say with radius, whatever. But there's only one circle A prime and there's only one ray A prime. Okay, so I think we know where we're at and we put that up there. We have copied a segment. That's it. Now I want you to think about this though. What if I asked you to double that segment? Not too much more complicated, yeah. Okay, so she's saying make the circle double the length, but if we have this compass and we measure this out to get to double the length, we've got a little bit of a problem because we have to put that slider over here and then we move the slider and all of a sudden the slider is length. We don't have it really measured and whatever. But you have the right idea. We want to double it. Here's what we do. We mark this, we take this same setting, and we go like that. Okay. And so you would just extend it and so on from there. Okay. So that's the kind of thing that you're going to do with copying and whatnot. Okay, moving to copying an angle. This is probably the hardest of the four. There we go. Okay, so copying an angle, it's also the same thing as constructing an angle congruent to the given angle. If you understand that idea, that's what we're going to do here. So I'm going to go through the steps and then we are going to come back and talk about why these steps work at different parts. It's important you understand that so you're not just like, she's doing these random steps, whatever. It makes it easier to do other proofs if you understand where these are coming from. Now, we're going to start off the exact same. We're going to plot A prime. In this case, it's A prime because it's the vertex. Okay, so we're plotting A prime. We're also going to start off with that ray starting at A. So we're going to make a ray from A prime. This ray is actually representing one of the two sides. I'm going to have it for me represent the side that's AC. Okay. You can do it in whatever direction you want. It all works. Most of you, when you're copying an angle, are going to do it kind of in the same direction that is. So I'm going to do my ray down here. Not that you have to do that, but just to kind of get that idea. Anytime you draw a ray and you find out you need it longer later on, you can always extend it. That's why it's a ray. Okay? Or you can make it long at first and you can shorten it later on, whatever you need to do, you can always do that. Okay. So we made our ray A prime. We are again going to try to find point C. So what this is going to do is that we are going to measure. That's not enough. Oh, we're going to go with that. That's enough. We're going to measure our AC. Okay. And from that, we're going to plot circle A prime with radius equal to AC. Okay. Same steps that we just did. It seems kind of crazy, but it's the way that this starts off. Is that I'm going to measure AC, and then I am going to make that circle. This circle in this case, I'll do the best I can there, needs to be a little bit bigger. Okay, notice what I did there. It essentially needs to be as big as that opening of the angle A. Okay. So you want to make it at least big enough that you would cover the opening. Again, you could always come back and extend it, but it's easier with the circles to erase than extend. So I just always kind of make them a little bit bigger. Right. We also need to make, this is the part a lot of people skip, we need to make circle A with radius equal to AC. Okay, because we need something we're going to copy. We'll talk about that in a second. So not only was I making that circle A prime with this radius, I also need to make circle A. When you do this, I will tell you right now that as you can see on my board, it does not go through point B. I specifically gave you 3 points to where those two B and C will not be the same distance from A, okay? Just so that we don't have that confusion. It does not go through B there. Now, the reason that I just did that is because I need to find 2 points on angle A. Again, make sure you think about these reasons because this is what's going to apply with what you're doing the next 2 days. Okay. I need to make 2 points on angle A that are the same distance from A because it gives me a place to measure the opening of angle A. Okay. I could have done all of this in here if I wanted to and done something like that. Okay. I chose to use one of the points because it's easier when you're describing what you're doing if there's already a point there. Okay. But all I had to do was I had to find 2 points that were the same distance from here so that I'm going to be able to measure the opening of it. Imagine this, if I just told you without doing any of that to measure the opening of this angle, okay? You could measure it here, you could measure it here, you can measure it here. And imagine what we say by measure right now, so in construction, it's a length. So that changes no matter what, okay? So if you don't have the where on the angle do you want me to measure and where should I mark this, then you don't know the measure, okay? So that's what this is doing. Now, in order to continue with this, I need to identify this point right here. I'm going to call it point D. As soon as I use my pen, I've got to go make a step. I'm going to say step 6 here is to plot D at the intersection of, who wants to give it to me?
Circle A.
Yes, and?
Ray A. B.
Perfect. At the intersection of circle A and ray AB. Using our notation there, I didn't even have to write the word ray. Just use my notation to do it. Now I also, and there's not like a good order to these like 3 through 7 or whatever, but I also need to plot a point right here. So I'm going to plot point, I'm going to call this C prime because if we understand what we just created, we copied C. Okay, I'm going to plot C prime at the intersection of, and we'll just call it again, ray A prime and circle A prime. Again, my steps that are in like 3 through 7, there's kind of lots of orders I can do to those, but you need to get all those pieces down. Now, the last piece of this puzzle is to figure out where D prime is, not B as in boy, D as in dog, D prime. Okay, that's the one that I'm going to have to make because I picked these 2 points that are the same distance from A so that I can measure that opening and then I can measure the opening. It's fine. Where do I want that other ray to go? Okay, that's the idea. Now, measure again does not mean ruler, it means compass. So what I'm going to have to do here, and it doesn't matter which way you measure it, but I'm going to measure the opening between C and D. Okay, if you want to, and again, this measure step is really not one you have to write, but I'm measuring segment CD, which means with your compass, you're gonna put, for you guys, you're gonna put that little circle part on one of the points and you're gonna extend your slider to the other point. You're measuring CD. You do not have to make a circle at C or at D. You're gonna go over to C prime and you're gonna make, I'll write it here. You're gonna make circle C prime with radius equal to CD. All right, so I'm measuring that opening of CD. I'm coming over to C prime and I'm making a circle. That's a really bad one, but that's the idea. The only part of that circle I need to see is where does it intersect the other circle, right? I used one circle from A prime that found the distance that D was from A, and I use another circle from C prime that finds the distance D is from C. That intersection right there, we're going to label D prime. So we're plotting D prime at the intersection of, in this case, we can say circle A prime and circle C prime. Yes.
So how did you get to D prime again? Because you have to draw B, line B in order to get D.
You do not have to draw B in order to get to D. I measured the AC, and I could have used B instead of C, but I measured AC. I measured the distance out to C, and I marked off that point. So this is also from A to D is the same as A to C. So those two distances are the same there. So this marking right here is the A to C, A to D radius. Again, the steps are telling you all this stuff. And then I measured the opening of the angle at that point. Okay. And so that gives us those two things that intersect. All you're doing now is you're taking and you're making that ray. Okay, you're creating or plotting or drawing, whatever you want to say, A prime, D prime, and that finishes off. It's a ray. That finishes off your angle. Now, are there other ways to do this? The answer is yes. If you get to something and you're like, can I do this? Does it work? Ask. This is the one with the least number of steps. And there's different things. You could take out like step 3 measuring and step 8 measuring. You can get rid of those. I'm not worried about the fact that it's like 11 steps or whatever, but it's the least amount of work to get to this one. But there are other ways to do it that may make more sense to some of you. And you're welcome to ask about them, right? Especially in the next 2 days when we're doing some of the other stuff. You can do that. But again, the whole idea of copying an angle is that you can't simply measure the opening of an angle because we don't have a compass. Right? We're not using the compass. We're using we don't have a protractor. We're using a compass. So in order to measure an opening, okay, we have to measure a distance. And if you just randomly measure an opening, you don't know where this opening is and where do I place it. Like if I measure this opening and then I place it over here, that angle is not the same one. Right? So you have to have a distance away measured, and then you can measure the opening from there. Yes. You do not. We're doing Euclidean constructions. You have a straight edge and a compass.
So there's just a protractor on here for no reason.
You also have a ruler on there for no reason. We talked about that. So you're doing a Euclidean construction. All you have is a compass and a straight edge. Okay, that's all that you can use there. That's how you copy your angles. Okay. Step 3 here. Copy 3. Next page. Okay, this may be the easiest of them. I'm going to go through it in the steps that I have and then explain what you could change a little bit to do it. But what we are doing here is constructing a perpendicular bisector of a segment. This is also the way with one extra step of drawing one extra point that you find a midpoint. So either one of those are done through the same construction. Okay, you're going to have a lot of perpendiculars. Because anytime you need 90 degrees, perpendicular bisector, that's what it comes up. Okay. So to do a perpendicular bisector, you are essentially going to make circle A with radius equal to AC. And you are going to make circle C with radius equal to AC. Now, notice I skipped the step that says measure AC. Because really, in order to make circle A with radius AC, you have to measure AC. Okay, that's why that wasn't a step that is required, as long as you mark what you're doing there. Okay, and then you go from there. It will probably be helpful for all of you, lefties and righties, everybody, to flip the paper over at some point to do the other one. So the easiest one for us that are right-handed is the circle A1. It's going to go this way. And then if I turn the paper, then circle C does the same thing. If I'm left-handed, the circle C is the easiest one to do. And then turn the paper, it's easiest for the other one. So if I'm right-handed, I'm making this. Now, in order to do this circle, you need about a half circle here. Okay. I'm going to have to find where these two circles intersect up here and down here. So I'm going to measure this out, and then I'm going to turn my compass, and I'm going to make best I can. Yours should go through C. Again, I'm just sketching them in with a made up compass here, you guys. So I'm going to make that, and then I'm going to turn my paper instead of become left-handed like I have to do for a second here. The board doesn't turn. Again, yours should be way more accurate than mine. I'm not actually using a compass up here. So. Two steps right there. It's essentially the main two steps of doing a perpendicular bisector. You do need to do a few more things so you don't actually have a perpendicular bisector. You can probably see it, but make sure that you think about, okay, what am I doing? Well, if I want to connect 2 points, I can't simply say make segments because I don't have a name for it. So before I can do that, I have to say that I'm going to plot, and I'm going to call them E and F. Plot E and F at the intersections. It doesn't matter which intersection, which one is, okay, of circle A and circle C. So if you tell them to plot E and F there, even if they do it in opposite order of you, the next few steps that we do will still work exactly the same. So you can just simply put them into one step there. But you do need to plot 2 other points, name them, so that you can use them. And then, yes, I am going to connect those. Now you can, and maybe I'll say draw in this case. You can draw a segment EF, you can draw a line EF, you can draw a ray EF. It does not matter. Okay, I'm going to draw a segment EF, but like I said, it absolutely does not matter which one of those things you do. You're going to connect those guys. And that is your perpendicular bisector. We made a 90-degree angle and it split that segment in half. Yes. Not an extra line. Okay, so we're going to plot, I'll call it point G at what? What do you say then, Cora? Perfect. Of segment AC and segment EF is exactly what you do there, right? So your midpoint is just going that one step further to say, hey, there's a point. Whenever you have an intersection of 2 segments, of 2 arcs, of an arc and a segment, whatever, you can make a point and you can talk about that intersection. But yes, that's your extra step for your midpoint there. Okay. Now, there's a few things that come into play here. Do you have to use a radius of AC? Absolutely not. Okay, you just have to make sure that whatever radius you use is bigger than half of this. You cannot do this. That's what I'll get a lot if you look at this. Okay, you cannot do this and tell me that you found the midpoint. You don't have enough data there to know that they're exactly in the right place, whatever. We need to find 2 points to make a segment. Okay, as we go through this. But as long as those 2 little guys are something like this, you can do the same thing. Or if they're something like this, you can do the same thing. Okay, you find those 2 intersections. You also cannot find the perpendicular. If you imagine this is my segment here, and I just drew these guys. Okay, you can't find the perpendicular from here and just randomly look at it and say, oh yeah, that's perpendicular. You have to have another point. There's nothing that says that this is where that line would go. In that case, you have to have those 2 points that are there. Anytime you need a perpendicular, you're gonna be doing a perpendicular bisector. So you may have to find where are those 2 points that are the same distance away or whatever. There's different ways to do that. Okay. Any other questions on this one? Okay, last one. Okay, so we are going to bisect an angle. So in this one, if you can imagine, so don't draw any of this yet, but I'm just going to kind of draw the end results so that we can get back to the beginning. We need something like this, right? We need to split the angle in half, right? That's not the greatest drawing, but you get the idea. In order to do that, what I need is I need some point over here that's in the middle of the angle. Okay. So what we're going to do is essentially like copying an angle, where we're going to find these 2 points that are the same distance from A. So we're going to find this point C and D that are the same distance from A, okay? And then that, if you can imagine, creates a segment. And look at this line, this segment. This line is the what of this segment? Perpendicular bisector. So all we're going to do is make this arc so that we find these 2 points that are the same distance from A. And then we're going to do a perpendicular bisector of those. Okay. So if we put all of that together, this is how we find an angle bisector. Okay. First thing that I am going to do here, I don't have to remake A prime or anything like that. I'm doing it all here. I'm going to do circle A with radius equal to AC. If you prefer to use B, go ahead. I don't care. Okay. Circle A with radius AC. I'm going to plot my point D. That means I need to say that. Plot D at the intersection of, in this case, it's ray AB and circle A. Make sure you don't say at the intersection of ray AD and circle A. I'll get that once in a while. D can't exist until it exists, so don't use it to get to it. So we've got D there. Then we're going to do the perpendicular bisector. So what does that require? Well, the easiest way to do it is to make circle D and circle C with radius equal to, I'm going to say CD. I'm just going to measure that opening. Does it have to be CD's measure? No. It has to be over the distance between C and D, over half the distance. Okay. The easiest way to write the rules here is to do it with points that you have. So that's why I'm using C here. So I'm going to make 2 circles and I need them to intersect out here. So it's up to you how much you draw, but I need them to intersect out here. So I'm measuring that opening there. And then I'm going to slide my compass out and get a mark. And do the exact same thing from the other one. Again, turning your paper is your best bet on a lot of this. I have it at a good angle. Hopefully we've got the same idea for the last 2 steps, or we've got the idea for them. We're going to plot, I'm going to call it F. You can call it whatever you want. Plot F right here. That's at the intersection of circle D and circle C. And then we just need to draw ray AF, which again is a straight edge part of the problem there. Yes.
So how did you get the 2 curved lines that met up to F?
It's circle D and circle C with a radius of CD. So if it says that, then that means circle C means I'm putting my center of my compass at C and measuring CD as my radius. So my slider is going to go out to D. And I'm going to make that arc. And then with that same measure, I'm going to go center at D and do the same thing. Anybody else have questions on any of the 4? Okay, so if you know how to do these 4 constructions, you can do every other construction I ask you to do, as well as a lot of other ones that maybe I don't ask you to do. Those are the only 4 constructions you do. It's just a matter of the combination of what do I need to do? Do I need to have an angle? Do I need to have a segment? Do I need to copy an angle, copy a segment, whatever, and kind of go from there? Okay. So what I'm going to show you now is how Delta Math sets up. Okay, is how Delta Math works. We're probably not gonna have enough time to really start it, although I guess you guys have the packet here too. So if you want to start it for 10 minutes, you do. Because you'll be in here for your homework. But I'm gonna show you how the Delta Math works within all of this, because we have to understand what we just did here in order to do it in other ways. Okay, which is why I don't just want you to be able to physically do this. I want you to understand concepts as well. So if you just look at the board here, I'm gonna get it. What? No, we have an assembly. Okay, so if this was your, this is not one of your problems, but you have a 6-question Delta Math assignment. If this is one of your pieces to it, let's see if I can, there you go. And you need to think about what you're doing. So a compass and a straight edge are the 2 things we have. So if you need a compass in this, you click and drag to draw a circle. So I could like draw a circle like this if I wanted to. I could draw a circle, maybe, let me get out of it, there you go. I could draw a circle randomly over here, wherever you want to do it. Okay, so within this, you can do that. If you need to measure something and then move the circle, let's say I needed to measure this one, and then I need to move it, I can take the center of it and I can move it, okay? So I can do those things. If you need to make that arc, all you have to do is all I'm doing is I'm just using my mouse right now, you guys. Once I go over the top of it, it turns into a pencil and I just kind of trace a little bit. You don't even have to trace perfectly, you saw me there. Just click and hold and you go. And then you get that arc. And if you need to move that same sized arc somewhere else, you can go from there, okay? So you can do whatever you need to with those. Segment, ray, and line are simply your straight edge. So if you need to take and you need to connect and, hey, I'm gonna go from here to here and I'm gonna put those 2 points, then you can do that. Okay, click and drag is all that I'm doing there. So all of the same things that you did today with a compass and straight edge, you can do using technology. If you, when you're making a circle, if you want to make the whole circle and draw it all in, then do it. If you want to make part of it, then make part of it. Okay, whatever you want to do from there. But you do have 6 questions on Delta Math that are essentially the exact same thing we did today. Okay, plus 2 other things that are a little bit of a stretch, but not much. And that's what you have to do. So it's up to you. Our assembly starts at 10:25. So you have 10 minutes right now if you want to grab a computer, or if you want to do it on your phone, you can do either one of those. If you want to sit and relax, that's fine too. It should be extremely easy because you don't have to